Welcome to our journey through the cosmos. Today we unravel the mysteries of how galaxies are made. From the fiery chaos of the Big Bang to the elegant dance of celestial objects, we'll witness the grand narrative of galaxy formation. Our journey begins billions of years ago, in a universe still young and finding its footing. Get ready to explore the intricate processes, the cosmic ballet of gravity, and the relentless cycle of stellar birth and death that have shaped these celestial wonders. Let's embark on this adventure, together, and unveil the secrets behind the universe's most magnificent creations. Imagine, if you will, a universe confined to a space smaller than an atom. Then, approximately 13.8 billion years ago, came the Big Bang, an unimaginable burst of energy and expansion, setting the very fabric of space-time into motion. As the universe expanded, it cooled, allowing for the simplest elements, hydrogen and helium, to form. This era, known as recombination, marked a pivotal moment. The universe, once opaque, became transparent, allowing light to travel freely for the first time. From this primordial soup, the seeds of galaxies were sown. In the vast expanse of the early universe, gravity began its work, drawing together the hydrogen and helium gas. Over millions of years, these clouds, vast and diffuse, coalesced under their own weight. Imagine these clouds as cosmic whirlpools, slowly drawing in the surrounding matter, growing denser and hotter at their cores. As these clouds contracted, they began to spin, like a figure skater pulling in their arms. This rotation, a consequence of the conservation of angular momentum, further intensified the gravitational collapse at the cloud's center. Deep within these swirling clouds, the stage was set for a pivotal moment in cosmic history, the birth of the very first stars. The universe, once shrouded in darkness, was about to be illuminated by the light of a billion suns. Within the dense, swirling hearts of the primordial gas clouds, temperatures and pressures soared. Hydrogen atoms, forced together under unimaginable force, began to fuse, igniting the inferno of nuclear fusion. Thus were born the first stars, massive behemoths unlike any we see in the universe today. These stars, known as population 3 stars, were composed almost entirely of hydrogen and helium, the only elements available at the time. These stellar pioneers were short-lived, burning through their fuel at a prodigious rate. They exploded as colossal supernovae, seeding the surrounding space with the building blocks of life itself. The heavier elements forged in their cores, carbon, oxygen, iron, were scattered far and wide, enriching the primordial gas clouds that would birth future generations of stars. As stars ignited and lived out their brilliant, albeit brief lives, gravity continued to shape the surrounding gas clouds. Star clusters, drawn together by their mutual gravitational attraction, began to merge and coalesce. These clusters, vast swarms of stars, became the building blocks of larger structures, proto-galaxies, the precursors to the majestic galaxies we observe today. Imagine these proto-galaxies as cosmic construction sites, buzzing with activity, stars forming at a feverish pace. Over time, these proto-galaxies interacted with one another, their gravitational dances pulling them closer, often leading to spectacular mergers. These mergers, colossal cosmic collisions, played a crucial role in shaping the morphology and evolution of galaxies. Through this chaotic ballet, a sense of order began to emerge. Over billions of years, the universe became a grand ballroom, with galaxies as the dancers their waltz choreographed by the invisible hand of gravity. These galactic mergers, far from being destructive events, were crucial to galaxy evolution. Imagine 2 spiral galaxies, their majestic arms swirling with gas and dust, drawn together by their mutual gravitational attraction. As they approach each other, their gravitational fields distort their shapes, drawing out long, luminous tails of stars and gas. These tidal tails, like cosmic ribbons, stretch out across vast distances, a testament to the immense forces at play. As the galaxies merge, their gas clouds collide, triggering waves of star formation that light up the cosmos with dazzling brilliance. These mergers could transform spiral galaxies into elliptical galaxies, their once graceful arms merging into a more rounded, featureless shape. The Milky Way itself bears the scars of past mergers, its halo containing streams of stars ripped from smaller galaxies that ventured too close. But there's an unseen player in this cosmic drama, a force that shapes the destiny of galaxies yet remains shrouded in mystery dark matter. This elusive substance, invisible to our telescopes, makes up the vast majority of the universe's mass. Though we can't see it directly, we know dark matter exists through its gravitational effects on the visible universe. It acts as an invisible scaffold, its gravity shaping the distribution of galaxies and influencing their evolution. Imagine dark matter as an immense invisible web, its filaments stretching across the cosmos. Galaxies are strung along these filaments, drawn together by the relentless pull of dark matter's gravity. Without dark matter, galaxies would fly apart, their stars scattered into the void. Within the swirling disks of spiral galaxies, new stars are constantly being born. These stellar nurseries, vast clouds of gas and dust known as nebulae, are scattered throughout the galactic disk, glowing with an ethereal beauty. Imagine these nebulae as cosmic wombs, where the raw materials for new stars, hydrogen, helium, and traces of heavier elements, are slowly drawn together by gravity. As the cloud collapses, it fragments into smaller, denser clumps, each destined to become a star. Deep within these collapsing clumps, temperatures and pressures soar, igniting the nuclear fusion that powers stars. Newborn stars, blazing with youthful energy, illuminate the surrounding nebulae, creating breathtaking displays of cosmic artistry. Star formation is a continuous process, ensuring that galaxies remain vibrant and alive, their evolution forever linked to the life cycle of stars. Today, billions of years after the Big Bang, the universe is teeming with galaxies, a breathtaking tapestry of diversity, each with its own unique story to tell. From dwarf galaxies containing just a few million stars to giant elliptical galaxies, home to trillions of stars, the universe is a vast and varied place. Spiral galaxies, like our own Milky Way, are perhaps the most familiar. Their graceful arms, swirling with gas and dust, are sites of active star formation, their brilliant blue hues a testament to the youthful energy of newborn stars. Elliptical galaxies, on the other hand, are often older, containing mostly older, redder stars. These galaxies, thought to be the products of multiple mergers, are often found in the hearts of galaxy clusters, where galactic interactions are commonplace. As we gaze out at the night sky, we are witnessing the culmination of billions of years of cosmic evolution, a testament to the power of gravity, the beauty of physics, and the endless capacity of the universe to surprise and inspire us. As we look up at the night sky, we are witnessing the ongoing story of galaxy formation and evolution. Each point of light represents a vast collection of stars, gas, and dust, each with its own unique history and destiny. The study of galaxies is a journey through time, allowing us to peer back billions of years to witness the universe in its infancy. We've uncovered the processes that drive galaxy formation, from the fiery birth of the first stars to the majestic dance of galactic mergers. But there's still so much we don't know. Stay curious and keep exploring the wonders of the universe.